This is number 10 in section 4.1. The question is related to how to use StatCruch, do the linear regression and also finding the correlation coefficients, draw the scatter plot. So the table gives you female MRI related to the IQ and male MRI and IQ data. So the question part A asking you to draw a scatter plot or say scatter diagram treating MRI counts as the explanatory variable and IQ as the response variable. So explanatory variable is your x coordinate, which is supposedly to be MRI, and IQ is the response variable, which should be the y value. So by this reason, you'll see at least you cannot choose B and C. Your answer has to be either A or D, because your x coordinate is MRI and y coordinate is IQ. So how to do a scatter plot? One more thing you need to pay attention for this question is, even though your data is separated into male and then female, but the question is ask for a general MRI related to the IQ, or say the other way, IQ related to the MRI. So when you open the data in the StatCruch, you need to do a little editing, okay? The first column is for female MRI. The third column is for male MRI. You need to put these two columns into one. So to make it clear, I'm going to change this label to just MRI. So I do control. Okay, I'm going to select. I'm going to select this whole set. Control copy. Control C, copy, Control V, paste. I think I lost one here. Okay. And then you select all the MRI for male, copy, paste. Okay, so this is all the MRIs. And do the same thing for the IQ. I'm going to copy all the female IQ, Control C, copy, Control V, paste. And also here, copy, Control C, paste, Control V. Okay, so this are the 10 sets of data with general MRI, and let me change this label into IQ. Sorry, IQ. Okay, cannot type. Now you need to do the scatter plot using graph, under graph, and a scatter plot. Select your x value as your explanatory variable, which is MRI, and y variable as your response variable, which is IQ. And then all you need to do is to compute. See, that comes out to be the set of data, the scatter plot. Then you compare. As I mentioned, B, C will not be your answer. You just need to look at A and D to see which one is more like the question, the graph you just got. I believe that should be D, if you compare with what we have here. Okay, if you put the cursor on any of the point, it actually gives you the number there. Okay, so I decided to pick D, check answer. Yes, nice work. Good. And the next question asking you to compute the linear correlation coefficient between MRI count and IQ. So notice this one is not separating your gender as female and male, so it's a general case. Then I need to pull out the data I just created by myself, which is, let's close out this, which is your MRI column and IQ column. Do a stat regression, simple linear regression, and select your x coordinate to be MRI, your y coordinate to be IQ. And there are hypothesis test, confidence interval. Those two concepts we'll be talking later in the semester. Right now we only need the regression, so all you need to do is compute. Now you don't have to worry about all those that will be later in the semester. All you need to look at is this R right now for this question. R is correlation coefficient. In this case, it's 0.6559. Rounded to 3 decimals should be 0.656. So I know it's 0.656, but does that mean it has a linear relation or not between MRI and IQ? I need to go back to look at the critical values. I have 10 sets of data, so you need the n is 10, and I have the critical value is 0.632. So the data, the correlation coefficient I got is 0.656, which is bigger than your critical value. That means I do have a linear relation. So I'll pick yes. Let's see. It's down here is 0.656. Okay, check answer. Good job. So that's one thing you need to look at this critical value table. Okay, draw a scatter diagram, but use a different plotting symbol for each gender. So notice this one says each gender, and I do have two different colors, purple and blue, representing female and the male. Okay, still the same thing. If you look at the x coordinate is IQ, this one is also x coordinate is IQ, then I don't pick this two. B and C is not right because your explanatory and the response variable is wrong. Okay, so we will decide if it's A or D by doing a scatter plot separately for male and the female. So I think I still have the data out here. So going to here, close out that one. Now I need to do the scatter plot separately for the first two columns and third and fourth column. So I'm going to graph scatter plot. X coordinate should be female MRI, Y coordinate is female IQ, and I will compute. This one is for the female one. So I have 5 dots, and look at the shape to see is that more like in A or is it more like in D? I think it should be A, right? Look at this 1 point, 2 point, and then that's the same as this point and that one. And then you also have 2 points actually almost horizontal, so that's this 2 points. And then there's 1 point here. Okay, so I guess it should be A. To confirm that is right, I will need to draw another one for the male. So option, edit. I'm going to change the female one into male and Y variable into male IQ, and then compute again, and then you'll see I got something very similar as first point, second, and then this is the top 2 points, and then I have this point, and then the other one is a little bit lower, and the last one is lower here. So notice the coordinate here is 135 for the Y value, even though this is higher, but this coordinate is 130. So you are actually right here somewhere in the 135 here. Okay, so I think part A is the answer. Okay, let's pick that and check answer. Well done, good. Next question, compute the linear correlation coefficient separately for female and male. So we'll do that process again, but instead of using that new column, I will be using only the female first and then only the male. Okay, so stat, let's close out this one, and then stat, do regression, simple linear, and I need to pick female MRI, female IQ, and then compute. You'll see this is your R, which is 0.460. So I will type in 0.460. Okay, and then asking for the male one, I need to do that again, pull out my data, and options, change the edit into, instead of female, I'm going to put the male, MRI, and male IQ, do the same thing, compute. You'll see R is 0.431. Okay, so that should be 0.431. Okay, check answer. Great. Okay, last question. Yeah, comparing those correlation coefficient with your critical value. So notice N is 5 for the male and also 5 for female because we only have 5 sets of data. So you notice, go to the table for critical value, look at the 5. Your critical value is 0.878, and I believe both two correlation coefficients is smaller than the critical value. So that means there is no correlation, because the correlation coefficient for female is positive, and then absolute value of the correlation coefficient, let's see, 0.460 is less than, no greater than, remember that number we pull out is 0.878. Let me double check if it's that right or wrong. Yes, 5.878. Okay, so that is your critical value. The critical value for the female data. So your correlation coefficient is smaller than that. So there is no relation between MRI counts and IQ for female. Because correlation coefficient for male is also positive, and then absolute value for the correlation coefficient is 0.431, as we just find out, and that one is also no greater than the critical value, same critical value, because your sample size is the same. Okay, and then that has no relation existed between that, because your correlation coefficient is less than the critical value. Okay, let's check the answer. Well done. Great. So I hope you understand this question now.